All right, everyone. I think we'll get started here. It seems like everyone's pretty much settled in. So the final presentation here, Jim from the city of Raleigh is going to be speaking. I always find it interesting to listen to talks about AI and actually understand the use cases a little bit more, coming from the AI background and understanding it's been a bit of a buzz term over the past few years, but now we're seeing a lot of use cases and seeing how it can be used for positive and for change. And with that, I'll bring Jim on to introduce himself and to offer a great presentation.
So I know I'm standing between you and an adult beverage, so I'll try and keep it pretty quick. So my name is Jim Albrecht, City of Raleigh GIS and Emerging Technology Manager. This is a project that the folks on the screen have been working on for a number of years, and we're really super excited about it, and we'd like to kind of talk about it. But one of the things the presentation is called, using machine learning to solve real world problems. And I tried to think of other examples of how we're using this. And what I wanted to try and do, which is probably going to be a terrible idea, is I'm going to see if I can get ChatGPT to create like an opening statement for me for this presentation. So I just wrote up something. Let's see if this works. So it says, write me an opening statement for a presentation at a GIS conference about computer vision, and I'm going to read it live, okay? Oh, an error, of course. I have actually another. Okay, so I did it a few minutes ago. Good morning, afternoon, evening, everyone, and welcome to this presentation on computer vision and GIS. As we all know, GIS has revolutionized the way we collect, analyze, and interpret geographic data. With the advent of computer vision technology, GIS is taken to the next level, allowing us to extract meaningful information from visual data such as aerial imagery, satellite imagery, and street-level photos. In this presentation, we will explore the current state of computer vision, maybe not, in GIS and the exciting possibilities it offers for the future. We will also discuss some of the challenges and limitations of this technology and how we can overcome them. So fasten your seatbelts and get ready for an exciting journey into the world of computer vision in GIS. So that literally was way better than anything I could have come up with. Okay, so a little bit about Raleigh. Most of you know, 500,000 people. One of the fastest growing cities in the country. We all live in North Carolina, and so we know that this is a really fast growing area that causes a lot of pressure for us to come up with really innovative solutions to solve a lot of problems. So what are the things that create the conditions where this makes sense? So the city does a citizen survey every 2 years. And sorry for the eye test, but one of the top two concerns that come back every time we do this is traffic and development, right? It's like top 1, 2. And secondly is that the citizens would like a priority to focus on the city being a smart city and leveraging emerging technology. So those are some of the conditions that provide us some kind of green lights to kind of explore things like this. So some other things that are happening is we've been fairly forward thinking about IoT, real-time data, the instrumentation of the city, plugging into sensors, whether they be in vehicles or sensors, and trying to better understand the city and share it back with those departments to make better decisions. Also, GIS is a core technology in the city. So we are using GIS as an integration platform across all data, all sorts of data, whether it be fixed asset or social services data. So it is kind of fairly well adopted across all city departments. So this is right. We may have seen this video on a commercial a few years ago, where you started to see computer vision kind of being applied to video in real time, and this was amazing 5 years ago. But the difference is this is City of Raleigh streets. And so when you bring it to department heads in transportation and planning, this is different than what they saw on the commercial from IBM 2 years ago, because it is, I know that car, I know that intersection, et cetera. So we had a smart city conference probably about 3 years ago. We invited actually Esri to help kind of present, do a keynote speech about the state of geospatial technology. There was a gentleman, Mansour Rad, who spoke, and about 3 weeks before the presentation, he called us and said, hey, I got this idea. And the idea is that in real time, we're going to plug into one of your cameras, and we're going to show it during this presentation. So at the, there was a couple hundred people at this conference, a lot of people from the city, and we showed this, which was in real time, a couple of intersections, and we were just counting cars. And we got a bunch of oohs and ahs, which was exactly what we were looking for. But we connected, the IT department connected with some of those department directors after the presentation and said, let's do it. You ready to scale? And they said, well, it's interesting. It's just not helpful. What we need is, I don't need to know how many vehicles you see in the frame. I need to solve an operational problem that I have. And this is one of the things, I'm not a transportation planner by any stretch, but this is a product that our transportation department pays to get generated all the time, right? Hundreds of intersections a year. And these are what are called turning movement counts. So up in the top left, you'll see a gentleman kind of with this abacus looking thing, and he's literally counting cars as they're approaching the intersection and leaving the intersection. And then this report gets generated that shows that on the Tuesday that he was there, this was the traffic. And that is used as input for roadway design and traffic analysis, et cetera. Okay, so those things are happening. Okay, so is there an opportunity to say, hey, instead of Tuesday at 2 o'clock, I can tell you 24 hours a day, 7 days a week. If today is different than yesterday, do I need to call somebody? And so that was really exciting to them. So again, this was early prototype, trying to take an intersection and just like start to track these vehicles through the camera frame and do homography to track them into spatial information. So each vehicle would be a track. So, right, just like I think every presentation I've gone to today has talked about continuity, staff continuity. We've had staff continuity. So we've had a little bit of difficulty kind of getting to leadership to talk to them over the last few years. So we have a new CIO. Awesome. We got this presentation. We're ready to go. So on the right is one of the things that we kind of had keyed up to show them. And I got really scared because this approach is actually going into the southbound lane. I was like, oh, we're all calibrated wrong, until we brought up the video on the left and saw that there was construction happening. So there was really, this was like, okay, it was an affirmation that we were kind of getting close to valid information. So this, again, this is like art for me. This is, looking at that intersection after a few hours. You could start to see this start to tell a story. And if we went back to that dashboard, that story would be quantifiable, and we could compare it over time. So technology. So we're using the computer vision platform we're using is from Nvidia. It's called DeepStream, or Metropolis is the whole thing. And literally, that team at the front page are the people who configured it. So it is, while it's not consumer-grade technology by any stretch, it is not rocket science. So it was, right, there's camera. I didn't know all this before we started, but there's standard camera technology, right? Streaming technology, RTSP, which is just a stream of video, and that just gets plugged into this platform. And the platform has levers and buttons that you can pull, that you can change how you configure what you look for, and objects you can kind of recognize and then track them. So where GIS comes in is this line going up to the top is this message. So it converts this video into metadata. And so that metadata might be a red Ford truck or a person walking or a bike. And so that metadata is a message. and that message can be consumed in any modern technology platform. So in our case, we're using kind of the Esri technology stack. So we're using a tool called GeoEvent, which kind of processes real-time data. And so we're just kind of subscribing to this message, getting that data, kind of generating geometry because it has a geometry kind of string in it, pushing it into Portal or wherever we're storing that data, and then we just put a dashboard on top of it. So obviously partners are really, really, really important. So again, we haven't spent a dime on this. So it's all kind of R&D pilot information, but we're working with, Nvidia has been a really good partner. They're obviously really excited to find a city that's willing to work enough to get this off the ground and tell people about it. Esri has been a really good partner on the R&D side, on the AI side. And then again, those people at the front of the deck, those are the people who work between 3 and 5 on Fridays on this, right? So they're doing it kind of because they're really excited about it. Now, the thing for me is this. This is, okay, right? I think we can solve this turning movement count thing. That's going to be easy, right? We'll figure that out. But there's so many other things that the camera is looking at that there's street flooding, right? So flooding is a massive issue in the city of Raleigh. Can we detect standing water on roadways and set up alerts, et cetera? Mode monitoring. So obviously traffic is important. Are people on bikes? How long are they waiting for buses? Are they walking? Where are they walking? So parking is also important. So we can look at loading zones and their utilization. COVID-related wellness checks, bus stop wait times, Vision Zero. I was talking to Brandon about Vision Zero. So there was a great presentation I saw from San Jose who was like, hey, when a car hits a pedestrian, there's a 911 call. I know that happened. But for every one of those, there are 50 car almost hit a person. And so these things could potentially pick up on those things, categorize them as events, kind of store them, and just identify places where that might deserve kind of more research. So that was it, 10 minutes. So, one thing I just wanted to kind of share is there are some challenges. The challenges are we're doing a pilot right now for intersections. Right now, the thing we're trying to solve is when a vehicle goes behind a streetlight or a pole, we lose it and then we pick it up again. So we gotta train our model a little bit better. I'm very confident that when we solve this problem, our transportation group will be like, great, I just want you to do this everywhere. And that's massive, massive amounts of data. And so figuring out kind of a strategy around how to store, maintain, retain for the right time, aggregate that data is something that we got to think through. So, any questions? Sure. So we, as I mentioned, we put together this pilot for that Smart City conference, and when we were putting it together, we just started to reach out to, we just had some contacts, and then all of the sudden, we ended up with the product manager of DeepStream and the marketing manager for DeepStream. I don't know how we ended up with it, but now they're actually proactive in reaching out to us to be like, hey, what can we help you with? In this case, I think we're a little bit on the bleeding edge. So they're really kind of interested in kind of pushing us over the finish line so that they can kind of market that as, hey, if they can do it, anybody can do it. So it's about training models. So and you could train the model to do whatever you want it to do. So right now, I kind of glazed over it, but we were using, Nvidia has out-of-the-box models. And so we were using what's called a traffic, which does 4 objects. It does car, truck, pedestrian, bike. So those are the 4. Now, when we talk to our transportation folks, they're like, well, I need to know I don't want to know if it's a pickup truck. I want to know if it's a heavy load truck. That's the thing I need. And so we would have to train the model to differentiate those 2 things. The model that we were using, there are hundreds of these models. Yeah. Any other questions? Yeah. Yeah. So, I actually heard Chad's name kind of pop up over here. If you know Chad, if you know Peter, if you know Justin, Julie, they're people that I get emails from at 7 o'clock on a Saturday that are like, hey, I just configured the blah, 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 check it out. And so they, like, innovation, working on this stuff kind of keeps them kind of going. And so we had kind of met with our leadership team early on to say, hey, I know we don't have funding for this. I know we don't have a project for this, and we have operational responsibilities. Would you be willing to dedicate some time for us to work on this because we really enjoy it and believe it has lots of business potential and value? And they said, yeah, go ahead. How about Friday afternoon? And so Friday afternoons, we started to work on it.
So similar projects that we've heard about are larger things like incident counts and whatnot. One of the issues that they come across is the privacy of the especially as you start integrating more machine to demonstrate that really is something about people. How have you guys dealt with that? Has it been a problem, or is it something that you're taking into consideration for future development like this, like you start to scale it and same thing from facing the problem?
So there's 2 things. In my opinion, there's 2 things here. One is the actual privacy, and 2 is the perception of privacy.
Yeah.
So we are doing AI at the edge. The computer vision is happening at the edge. So we're getting the video which is going, right now it's going to our traffic management center. We're just intercepting it and just kind of processing it. And then we're not storing, maintaining any video. Only the metadata is getting pushed to us. So right now that is car, make, model, color. That's all we're getting currently from that, the metadata. But we're very sensitive, tracking kind of New York City privacy, AI privacy policy stuff, and just being very thoughtful about what we share with the public, when we share it, how we share it. Yes. Yeah, it is. You got to thread a needle a little bit. And it is on one side where we have gotten feedback that they want us to be a smart city and do these things. We would love to do that responsibly. So. One more time. 4 intersections. So in this case, I said we allocated $0. So we got early on, we got Nvidia excited. They donated a piece of hardware. So there's a hardware in our data center, and it can theoretically process 60 streams of data. So right now we're doing 4, so we could do 60. There's 150 cameras in the city that are just traffic cameras. My suspicion is that if we're able to demonstrate this, it won't just be traffic cameras. It will be security cameras, and they maybe will expedite kind of deploying of cameras. But the idea is that we would ramp up to the 60, demonstrate value. Transportation has kind of given us a verbal approval to kind of say, hey, if you could demonstrate this value, we will fund whatever you need. There's all of us in IT know that there's so many considerations about like support and maintenance and, data storage and all that. So there's a lot of details that we haven't completely worked out. But the idea is that we would go, as soon as we can kind of prove this at 4, we'll go to 60. So in this case, that DeepStream kind of Metropolis platform comes with models kind of pre-built. So we are leveraging pre-built models. So it, as I mentioned, it's this thing called Traffic Cam, which is specifically trained specifically for traffic cameras. What the issues that we're running into is it's limited, and so we will need to add additional training to it. And our plan is to use the Nvidia, it's called Tawa, I think, platform to add additional training images, video to that. Yeah. So you'll see, right? So if I showed you this camera, that's all it can see. Like it's probably over here pointing instead of at the intersection. It just kind of lost. So we can, so we create this trajectory from the time it can kind of see that vehicle theoretically through the frame. So I said we had 150 cameras. Definitely, there's going to be a very small subset that are positioned correctly. So again, I get super excited about this stuff. So there's this other opportunity, which is now we can do multi-camera object tracking. So we could track objects across camera feeds, which is, in my mind blowing that we could do that. But now we could find those intersections that don't have good coverage, work with our transportation group to deploy another camera. So just to be clear, what's happening is in this technology, in Nvidia's technology, DeepStream, we're processing the data, and what's coming out is a Kafka topic. So it's a message, and that message is just a JSON object that has a geometry attached to it, and it's got timestamp, length, speed, make, model, color, and that's what we're actually processing into GIS. Yes. So, again, just to be transparent, like we turn it on, we get a bunch of data and we shut it off because it's literally, there's the velocity of the data. And so we've kind of started to kind of explore Databricks and kind of more robust kind of data science tools to kind of deal with the volume of data that we would envision needing to. Yeah, so there's two things. So one is what we're trying to do now is do it within the intersection, right? Not between intersections, just within an intersection. So in this example, say the camera was pointed over here and we were missing this whole thing, so we couldn't tell where it actually exited the intersection. We would deploy another camera here and be able to track it through the entirety of the intersection. But what you just brought up is, right, so when we started to talk to our transportation group, about, hey, can you deploy more cameras? We'd like to do, and they're like, yeah, can you track it across intersections? So there's a compute cost to that. So basically you have to store things. When it loses track of something, you would need to store it in memory. And again, just the velocity there's thousands of these things moving all around. So theoretically it's possible. But again, we're just trying to do it in the intersection. Yeah, so in this case, so this side of the intersection, say say a vehicle came here, and say the turn to take a left was here, we wouldn't know whether it went straight or took a left, because it's outside the frame. So we would encourage transportation to deploy a camera on that side of the intersection or somewhere else, so that we could say, okay, the red car 22, we track it through and we see which lane it's left.
And that's what is recorded
In the data would just be a single message that says, hey, from the time I got it to the time it left, I lost sight of it. This is its trajectory.
yeah, it's actually recording.
Yes, yeah. And one other thing that I didn't mention is all of these cameras are pan-tilt zoom cameras. And so we're calibrating these based on a view. If that view changes, none of this, all of it kind of falls apart. So we've kind of also talked about this idea of a home. So we'll set it in the perfect kind of configuration for the camera, set it to home, and then police, fire, EMS, they can move the camera, but if it doesn't get touched for 6 seconds, it will automatically go back to home. Great, yeah. So theoretically, the model is supposed to be trained in all weather conditions, but you can't, there's no way to do that. So what we had talked with transportation about is how about we'll go with 95% accuracy during daylight, fair weather conditions. Again, the other use cases that I talked about, which is standing water on the roads, that's not helpful when it's, completely sunny. So each model will have to kind of build and come up with some sort of SLA expectation around accuracy, conditions, those sorts of things.
All right. Thanks very much.
Thank you.